The amount of heat absorbed or released by a substance is given by Q and depends on the mass of the substance M, the specific heat C, and the temperature change delta T. The specific heat of a substance is the amount of heat needed to raise the temperature of 1 gram of the substance by exactly 1 degree Celsius. The units of specific heat are joules per gram per degree Celsius or calories per gram per degree Celsius. The temperature change given by delta T is calculated by taking the difference between the final and the initial temperature of the substance. This table shows the specific heat capacities of some elements and compounds, and you see that some of these substances like silver, titanium, aluminum, copper have lower specific heats or heat capacities, while some substances like water have very large heat capacities. Now, aluminum and copper are used in cookware because of this specific characteristic of having a lower specific heat. These substances change the temperature or raise the temperature pretty quickly with a smaller amount of heat. While substances like water that have large heat capacities are used as coolants, many of the instances because they can absorb a large amount of heat before they raise or change their temperatures significantly. In this example calculation, we are asked to calculate the specific heat of a substance given the amount of heat, the substance mass, and the temperature change. A 50-gram substance absorbs 21.5 joules of heat when its temperature is increased from 18 to 32 degrees Celsius. What is the specific heat of the substance? The equation gives us the specific heat of a substance by dividing the amount of heat Q by the mass and the temperature change. We have to show the intermediate steps of the calculation while being careful about the significant figures as well. So let us substitute the numbers first. The amount of heat Q is 21.5 joules. The mass of the substance is 50 grams, 50 point, note where the decimal point is, times the temperature difference final 32 minus initial 18 degrees Celsius. We have to solve for the parentheses first. So the temperature difference 32 minus 18 comes to 14 degrees Celsius, which has two significant figures. And now we're going to multiply 50 by 14. Both numbers have two significant figures. And the answer is 700. And we underline two significant figures because in multiplication we go for the lowest number of significant figures. In each figure we had two significant figures, so we underline up to 2 digits. Now we are left with 21.5 divided by 700. 21.5 has three significant figures and 700, as we underlined, should have two significant figures. So 3 sig figs divided by 2 sig figs, we have to round up the answer to two significant figures. And we are left with 0.031 joules per gram per Celsius.